Okay, so we're going to pick up where we left off. So we just finished doing the last problem, which was factoring this trinomial, and we are going to continue to factor in practice. So we're going to make a box, and k squared would go in our first box because it's the first term, and 20 would go in the last box because it's the last term. And 20k squared is the product, so that is going to go at the top of the x. And then 12k, or negative 12k, will go at the bottom. So I need two numbers that multiply to 20, but add to negative 12. And that's going to be negative 10k and negative 2k, because that will multiply to positive 20, but add to negative 12. And so you're going to go ahead and put those in the other boxes. All right, so from there, we're going to go ahead and find the GCF of each column or row. So the GCF of k squared and negative 10k would just be k. So k times what is k squared? K. K times what is negative 10k? Negative 10. K times what is negative 2k? Negative 2. And negative 10 times negative 2 is 20. So our factors would be k minus 2 and k minus 10. And it doesn't matter the order of how you put your answer. All right, so next one, we make a box. 6x squared goes in the first box. Negative 14 goes in the last box. We make our x, so I need the product of 6 times negative 14, and that is going to be negative 84x squared. And then 17x is going to go at the bottom. So this one's going to be a little tricky. So we need two numbers that multiply to negative 84, but add to 17x. So in this case, it's going to be negative 4 and 21. So 21x minus 4x is 17x, and 21 times negative 4 would be negative 84. So those, it does not matter where you put them, either way. And then from there, you find the GCF. So 6x squared and negative 4x would be 2x. So 2x times what is 6x squared? 3x. 3x times what is 21x? 7. 2x times what is negative 4x? Negative 2. And 7 times negative 2 is negative 14. So our factors are 2x plus 7 and 3x minus 2. All right, moving on to the next one. We start with our box. We put the first term, x squared, in the first box, the last term, 16, in the last box. We make our x, so the product of x squared and 16 is 16x squared. We take our middle term, negative 8x, that goes at the bottom. All right, so from there, we need two numbers that multiply to 16x squared, but add to negative 8x. So it will end up being negative 4x and negative 4x, because if we take negative 4 and multiply by negative 4, we'll get a positive 16. But if you add them together, you will get a negative 8x. So the GCF of x squared and negative 4x is x, and x times x is x squared. X times negative 4 is negative 4x. X times negative 4 is negative 4x, and negative 4 times negative 4 is 16. So what we have here is a perfect square trinomial because we are getting that same answer, the same factors. All right, this kind of looks like that one example that we did earlier. So we are missing the middle term, but we can still set it up. So we can't take out anything, and that's why I'm not doing anything similar to what we did on these two problems, because there's no GCF. So what we're actually going to do is something similar to what we did on this problem right here. All right, so going back down. Okay, so we have negative 1 would go in the last box. So our top of the x would be negative 9m squared, and the bottom would be 0. So I need two numbers that multiply to -9 but add to 0, and that's going to be 3m and -3m. And those are going to go in those diagonal boxes. And then we need a GCF of 9m squared and -3m, and it's 3m. 3m times 3m is 9m squared. 3m times 1 is 3m. And 3m times -1 is -3m. So our factors end up being 3m plus 1 and 3m minus 1, which looks like a difference of squares because they are the same terms but different signs. So parts A through C are trinomials, but part D is a binomial, yet they're all quadratic. So what makes them a quadratic? Well, it's that squared term. So they all have that squared, which makes it have a quadratic relationship. And then going back to this problem up here, so the reason why we got two different answers was because in the original quadratic, we actually didn't simplify it. So what we should have done was we should have taken out the GCF before, and the GCF of all three of those terms would have been 2. And that would give us the most simplified answer, because we can see that we could actually take something out from not that one, but this one. And then we could take something out from this one. And so that would give us the most simplified answer. Okay, that's it for this section.